What's that? Uh-huh. Yeah. But as much as no matter what I show you, you have to do the homework because that's where you pick up all the little intricate details of algebra. Right? You get way better at algebra when you do your homework. You have to. You have no choice. Okay, let's move on to the next example, all right? So for the next one, x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. That one looks a little worse, doesn't it? It looks worse because there's just more stuff there. So we don't have to do long division because the degree of the numerator is less than denominator, right? What if they're the same degree? What if they were both 3, x cubed and x cubed? You do have to do long division, okay? It's just if it's smaller on top, can you proceed? So if we go back to what that note was before, let me bring that page up again. So, okay, if degree of numerator is bigger, then do that. If not, the next thing would be factor the denominator. So that's where we are. Try and factor the denominator. So I'll do that on the side here. 2x cubed plus 3x squared minus 2x. Factor it. I can pull an x out. And the 2x squared plus 3x minus 2 is trinomial, so 2x, x, what do we got? Minus 1 plus 2. Does that work? That should be it. So that's a good example of a step that, I mean, I shouldn't in a Cal 2 class need to do that, but I'm doing it. Okay? Question? All right. X squared plus 2x minus 1 over, let's see, my new denominator is x, 2x minus 1, x plus 2. Only the denominator. You only factor the denominator. Okay? We all right? Okay, the next step, and I'll go back. After we factor the denominator, is that for every linear factor, right, for each one, I create this a over the linear factor, and then if I have more than one, at b, and then if there's more than 2, then I'll use a c. Okay, so all I'm doing is this part right here. I have linear factors. So I'll highlight my linear factors. I have an x, I have a 2x minus 1, and I have an x plus 2. So I have 3 distinct linear factors. Distinct means different, right? Each linear factor is different. So I know that this integral can become something over x plus something over 2x minus 1. I forgot my integral sign in the front. 2x minus 1 plus something over x plus 2. But the something on top I don't know. So that's where I come in and I say, okay, that's A, that's B, that's C. Make sense? The question now is or the issue for us now is to figure out what A, B, and C are. Yes?
You did this like twice. You took the whole thing that's in the top and put A, B, C.
I did this twice. What?
In the equation before,
Mm-hmm.
you substituted the
Yes. So it's the same principle. If we had 4 distinct linear factors, then we would have A, B, C, D. Yes. That's what I'm going to do right now. I'm about to split this and now say, okay, let me go get A, B, and C. And I'll come back to the integral. So what I know is that the left side, right, the integrand somehow turns into this. And what did we do last time? Multiply everything by the LCD, right? Now I'm just going to write what the LCD is over here. All right, that's my LCD. So I have to hit each one of those with it. What happens when I hit the left side of the equation with the LCD? Everything goes away except the numerator, right? And that'll always be the case. Now, what happens when I hit the A over X with it? What's still there? 2x minus 1 and the x plus 2. And then what happens when I hit the B with it? The 2x minus 1 cancels, so you're left with the x. I didn't need it in parentheses, but I put it there. X plus 2. And then, finally, C, x and 2x minus 1. Excellent. Any questions? We're trying to find A, B, C. Let's try and get A. Talk to me about how I can get A. Yeah, if I'm trying to kill off these two guys, I can choose X to be 0, right? And it'll kill off both of those. So you see, again, that's a clever choice of X to kill everything off except the A. So I'm going to come in through here, let X be 0, and then rewrite everything, left side and right side. So what happens if you plug in 0 on the left side? You get negative 1 equals A times 2 times 0. Minus 1 is negative 1. And then 0 plus 2 is 2. Y'all see where I'm getting that? Okay. Plus, everything else goes away, doesn't it? Yeah. So what's A? 1/2. All right. I've got 1. 2 more to go. What should I let X be now? X be, so if you're trying, look, I'm going to try and get B now, right? So how can I kill off A and C? I have to use the 2x minus 1 factor, don't I? And make that one be 0. Because that will kill off those two without killing off the B. So X has to be 1/2. So let X be 1/2, and you've got to plug that in both sides. So what do you get on the left side? 1/4 plus 1 minus 1 equals, the A one is gone, but the B one's still there. So B times 1/2 times 1/2 plus 2. And then what about the C? It's gone. Do y'all see where I'm getting this? No questions? Left side is 1/4. Right side, B times 1/2. What's 1/2 plus 2? 5/2. What's 1/2 times 5/2? 5/4. So 1/4 equals 5/4 b, which means that b is 1/5. How's that? Yes. Question. Okay, I was trying to kill off A and B and C, right? The A and C have this common factor. If I can make that go to 0, it'll kill it off. So I just set the 2x minus 1 equal to 0 and got x as 1/2. That told me what I needed to plug in to make them go away. All right, I need the C now. C is what? X, let x be what? -2. Do y'all agree if I plug in -2, it should kill everything off except the C? All right, I'm not going to do it, all right? I'm actually not going to go through the work for C. It should be -1/10. Do you feel like you could get that yourself? Okay. So I know what A, B, C are now. I can go back up to the integral. I have to start a new page. So the original integral, which was x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x dx, turns out to be the integral of a, what was a? 1/2? 1/2 over x. Now notice I put the 1/2 on top just like that. That's the way I've always done it. A over x, even if a is a fraction. Then it should be plus b. B was it 1/5 over, was it 2x minus 1? You got to make sure you get the a over what you said it was supposed to go over, the b over what, you can't just like throw them wherever you want. And then the last one is -1/10 over x plus 2 dx. Every single one of those integrals is of the form of the problem I put on the board as I walked around and checked homework. Integral d over ax plus b. So we get 1/2, what? ln x? Nope, 1/2. A in front. Plus 1/5, but then what about that 2 in front of the x? So 1/10 ln 2x minus 1 plus, or minus I should say, 1/10 ln x plus 2. Plus c, done. Yes. You mean before, you want to do that before the, you could have, it would have turned into what? 1 over 10x minus 5? It's 1/10 the natural log of 10x minus 5. Okay. Well, that's a good question. Is that the same or not? Yeah, but what do you do with that 5? Okay, look at this right here. Here's the question. I'm going to get rid of the absolute values just to make it a parenthesis. Just, won't it be 5 out here, right? Times, what is it, 2x minus 1? Right? And then property of logs. Natural log of u times v is the same as natural log of u plus natural log of v. Natural log u times v equals natural log u plus natural log v, right? Okay, so right here I have a u and here's a v. So I can split this up. 1/10 natural log 5 plus 1/10 natural log 2x minus 1. Agreed? 1/10 natural log 5 is a constant. So it's the c. It goes with the c. See, because look, we're not saying, you have to be very careful with this. We're not saying that this equals this, right? We're saying that when you integrate that yellow, either one of those two answers is correct because they're off from each other by a constant. It's a good question, but okay, algebraically, these two are not the same. But in the context of integration, they're off by a constant, and that's okay because our entire antiderivative is always off by a constant. That help? All right. Now, let's take a look at something a little different now. All right? How we do? Golly, man. There's not enough time. All right, I'm going to take us straight to this integral here. X to the fourth minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x minus plus 1 dx. So what would be our first step? Long division. Now I'm not going to do it, okay? I'm going to take you to what you would get if you did long division. They go through it in the book. This problem is example 3. They don't show the long division either, okay? But I'm just telling you that's what they did. Yes.
So we did the long division because the power on top is bigger than
Because the power on top is bigger than the power on the bottom. And you always have to start with that. So if you do long division, you should get 1 plus, sorry. X plus 1, doesn't matter if I write it the other way, but plus the remainder you wind up with is 4x over the divisor. Is everyone okay with that? Long division right there. Okay. Now you can do x by itself. Integral of x and integral of 1. Those are no problem. The only issue we have is this right here. So I'm going to go now to scratch work, and I'll come back up here in a little while. I'm supposed to take that and do what with it now? Factor the denominator. Now that denominator, I'm just going to say it. I'm not going to work it out. It's grouping, 4 terms, grouping. If you do the grouping on that, you should get this. 4x over. And again, the book does this for me, so I don't have to. You should get x plus 1 times x minus 1 squared. That's what you get if you do grouping on that denominator. Okay? Now, we know how to deal with a linear factor. When I'm trying to do partial fractions, for every linear factor, I put a over that linear factor, right? That's what I've been told. But we have not dealt with a linear factor to a higher power. Okay, so notice we have linear factor squared. So if I go back to my notes here, linear factor did that. Repeated linear factor. That's a linear factor to a power. What you have to do is you have to go some number on top of the linear factor to the first power, then some other number on top of the linear factor to the second power, plus, and you keep doing number over linear factor until you get to the power that was here. That makes sense? So if this was a 5, I would have like a over ax plus b, then I'd have b over ax plus b squared, then c over ax plus b to the third, then d over ax plus b to the fourth, and then all the way out to the fifth power. Okay? And for this problem, there's only 2 because it's squared. We're going to have to talk about your next test, what we're going to... Yeah, you'll be able to get to this in the notes. Yeah, because I copied and pasted that page in here. Oh, look, and I even put this over here. I did that formula right here, but without the D on top. And I even did that formula with a power. But that's neither here nor there. Let me get back to this one. All right, so let's try and break this sucker down. So this should equal, let's take care of the x plus 1 first. The x plus 1 is just a linear factor by itself. So I'm going to put a over x plus 1. Plus, now, my next one is a repeated linear factor. So b over x minus 1 plus c over x minus 1 squared. Do I need to go plus d? No. As soon as I get to that power, I'm done. But see, the power would keep coming up. Questions? LCD. With both, if this was parentheses, and then squared, you would have that squared. You could apply it to this one, so that would become an x plus 1 squared, and then that one to the fourth. And then this one would have a over x plus 1, b over x plus 1 squared, then c over x minus 1, and yeah. Okay, LCD is everything, right? X plus 1 times x minus 1 squared. When I multiply through on the left side, what happens? 4x equals a x minus 1 squared plus b x plus 1 x minus 1 c x plus 1. Yeah, when my LCD multiplies through, here is my LCD, x plus 1, x minus 1 squared. That has to go through to each one of these, right? Only 3 of them there. When it hits the first one with the a, I lose the x minus 1. When it hits the b, I lose the x plus 1. On the b, I lose one of the x minus 1s, but one of them is still there. So I have both on the top. And then on the last one, I lose the squared, the x minus 1 squared, but I still have the x plus 1. Is that okay? Yes. Okay, yeah. All right. Let's try and get a. Okay, so to get a, I look at b and c. How can I kill b and c without killing a? X would be -1. If you do that, and I'm not going to show the work. Is that all right if I don't show the work? I'm a horrible teacher, I know. What am I going after, A? I'm going after A, right? -1? Hold on. I'm not sure about that. Is it? -4. I'm going to double check this. 4 equals a -1 minus 1 squared. And the others are gone. Yes? Okay. So -1 is a. Okay? Next, get B. We'll look at that in a second, but here we've run into our conundrum, our problem. Up to this point, I've always been able to get A, B, or C by killing off the others, right? This problem is the first one where I try and get B, which means I say, how can I kill off A and C? Well, to kill A, you have to let X be 1, right? But that kills B. And to get C, to try and kill C, you have to let X be negative 1, but that also kills B. So there's no way to kill A and C without killing B. Does that make sense? And because of that, you cannot use the quick method. You have to use the longer method. So I said the quick method, always use it, but if it doesn't work, you have to resort to something that will always work. All right? So in the last 20 minutes, that's all I have time for is to finish this out, is to show you the long method. Now, you could possibly get C and then do some work and go back and get B. It can be done, but there will be problems where there's no way to get any of them. You'll never get A, B, or C by themselves. Okay? So I'm going to scrap this. This is extremely important that you understand what I'm going to do. I don't have to start the whole problem over. I'm still going to be sitting right here with this line, and I'm going to get out my eraser and erase this. You can just move down. Or should I leave that? What do you want? If anyone prints out these notes, do you want that there or not? Just leave it? Okay. Okay. I'm going to put no work. Bad instructor, bad English. How about that? No work. Horrible teacher. Can y'all shut the door all the way, please? Yes. Mm-hmm.
In the previous problems, you brought up the common denominator on top.
Uh-huh.
So when I wrote it down, I was writing a x minus 1 and x minus 1 squared over the common denominator. Because you only wrote a x minus 1 squared. So I don't understand why you did that. Both of them.
Okay, I see what you're saying. The reason why is because when you look for an LCD, you're looking for the least thing they all have in common, which for us will always be this denominator. I think what you're saying is you wanted to put an extra x minus 1 in here. Is that right? But you don't need it. You could do it, but you don't need it, and it will actually make your problem more complicated. The reason you don't need it is because by having the 2x minus 1s there, the squared, that when you distribute it through, it will cancel in the middle, and it will cancel on the C term. Your LCD, when you multiply two sides of a fraction by an LCD, you should have no more fractions. I don't know if that answers your question.
So if it's factored to whatever n is, you're always going to stack up the highest.
You're always going to use what's under on this side, what you factored over here. It's the same principle as having like 1/2 plus x over 4 equals 7. If I say find the LCD, you would use 4, wouldn't you? Because 4 is a multiple of 2 and 4. So you come in and multiply both sides by 4, right? You do not need an 8, which would be the 2 and the 4 together. But would an 8 work? Yes. Here it would. You multiply by 8, you still wouldn't have fractions. Problem with what we're doing is that the algebra, if you do it that way, it will be much tougher. I hope that answered your question. All right, so if the quick way doesn't work, we need the other way. Here it comes. What we're going to do is we're going to look at everything we have after our A and our B and our C. That's all the stuff with X's in it. And we're just going to multiply those out. Okay, multiply them out if you can. So like the x minus 1 squared, we can multiply that out, right? The x plus 1 times x minus 1, we can multiply that out. And then the x plus 1 at the end, we can't do anything with, right? So I'll rewrite this line to be 4x equals a x squared minus 2x plus 1 plus b times x squared minus 1 plus c times x plus 1. Now, why did I leave them in parentheses after I FOILed them out? Do I need the parentheses? Yeah, because it's a times that, right? So that a is going to have to distribute through to each term now. And then the b through each one. Follow? Okay. 4x on the left side must equal ax squared minus 2ax plus a plus bx squared minus b plus cx plus c. Y'all see what I did there? That all right? Now watch this. 4x must equal, I'm going to take my x squared terms and just put them side by side. I'm going to put my x terms side by side. And anything that doesn't have x in it, out here at the end. So my ax squared, my bx squared, just put them together. My minus 2ax and my cx, put those two together. This is just rearranging, right? I'm not doing any real math here. I'm just rearranging things. Questions on that step? Just kind of changing the way things are. Now the critical step. I'm going to look at the yellow, right? My x squareds. I'm going to factor x squared out. But I'm going to factor it out backwards. You know how we normally factor things out and we pull it out front? I'm going to put it in the back. It's the same thing, right? That would distribute through. We'd have the same thing. Do the same thing with the x's. But watch what I do here. Plus negative 2a plus c, factor the x out. So what I do is I always put a plus, and then whatever is in front of the x's, I put those in parentheses. Notice I haven't done anything with the 4x, right? I'm just leaving it alone. I didn't bring it over to join with those. Y'all still with me or not? Okay. And then at the end, I don't do anything to those, but I do put them in parentheses. And that's so I can illustrate the next point to you. On the left side of the equation, we have 4x, right? I'm going to scratch it out real quick, and I'm going to write something else instead of 4x. I'm going to write, I wanted red. 0x squared plus 4x plus 0. Isn't 4x the same as no x squareds, a 4x and a 0? If this side of the equation must match this side of the equation, then what's in front of x squared here? 0, which means these two have to add up to be what? 0. And then if 4 is in front of x, then these have to add up to be what? 4. And if 0's the thing by itself with no x's on it, then those three things have to add up to be what? 0. So don't we have 1, 2, 3 equations? And don't we have 3 unknown variables? A, B, and C. So we have a system of linear equations. So now I'm going to write that down. Now I like to draw some things here. 0 must be these two. 4 must be these two. And 0 must be these three. Now, it's not always going to turn out to be 0, and these problems can get pretty nasty. Because you can have A, B's, and C's in all of them. And then over here, you can have numbers in all of them. I have to go to a new sheet of paper here, virtual paper. You're going to help me out, right? The first equation said that A plus B had to be what? Equal to 0. The next equation said negative 2A, right? Plus C was 4. And then finally, A minus B plus C must equal 0. And I'm going to put this, a big brace in front of this. This is a system of linear equations. Now you could solve this one using like a substitution if you want to. Like we already know the relationship between A and B, don't we? Look at that first equation. A is equal to negative B, right? You can move the B over there to the other side. And if A is negative B, then you could replace this A with negative B. And then you could go and figure out what the relationship with C is. And then you go back up and maybe. So maybe there is a way to do this mechanically. But I said your graphing calculator is your friend. So I'd like to make sure we all have our graphing calculators. I can show you how to solve a system of linear equations on it. And we only have about 12 minutes left. Mm-hmm. The first thing I'm going to do, who does not have the graphing? I know there was like 2 or so people who didn't have them last. You still no go? Okay. You're going to look into it or maybe? Okay. Don't, like I said, I don't want you to go and spend $100 on one, but. All right, here we go. I'm going to first convert this system of linear equations into what's called a matrix. And all a matrix is a condensed way of writing a system of linear equations. And what you do is you look at the numbers, the coefficients of each of the variables. 1, 1, what's the number in front of C here? 0C, right? The second one here, negative 2, 0B plus 1C, and then 1A minus 1B plus 1C equals 0, right? Now you have to make sure that when you're going to set up a matrix, you have everything in order. So all your A's, B's, C's, and then equal. You can't have, that's why I lined everything up the way I did. You can't mix them up and write, B, then C, then A. Everything's got to be lined up. So in the matrix, I write 1, 1, 0, 0, then negative 2, 0, 1, 4, and then 1, negative 1, 1, 0. And sometimes we'll put a dotted line or we'll just put a solid line there, and we call that an augmented matrix. The way I want you to remember it is this. These are your A's, these are your B's, these are your C's, and then this is your equal sum number on the other side of the equation, right? Each one of these rows represents an equation. Now, on your calculator, I'd like for you to try and find a function. It is the function, it might be in your catalog, it might be in your matrix menu, and I can come around and help out, or you can help each other out. I want you to try and find the function RREF. Now, some of you who are familiar with your calculators know of other ways to put in a matrix and do this. If you already know how to do this, I'm not here to reteach you. But if you don't know, this method I'm giving you here, I think, is the most powerful. You find it? Okay. You got it? Who needs help finding RREF? Raise your hand if you need to find RREF. Yeah? Okay. Now, I want to write down how we're going to type this in. The reason why I do it this way, because there's other ways to enter a matrix, like I said, into these calculators. The reason I do it this way is because, as far as my knowledge is concerned, every TI calculator, no matter what model, will accept the input this way and give you an answer. As opposed to, like, the 84 versus the 86, the way you make a matrix is different. And so this should work for everyone. Bring up your RREF function on your calculator, and it should be sitting on a screen with an RREF with a parenthesis. Everyone there? Okay. Now, we're going to type in a bracket. This first bracket, just so you know what it means, this is telling your computer start of a matrix. It's telling it, hey, here it comes. Here comes a matrix, all right? The second bracket, which follows that, says this is the beginning of the first row. So it would be start first row. And then you start putting the numbers in for your first row, separated by commas. 1, I think the comma's above the 7. Or no? Yeah. Some calculators, I don't know if they're all. 1, 1, 0, 0. The entire row, first row. Commas between. Okay? What do you think comes next? Close your bracket. That tells you what? Tells the computer, end the first row, right? Start second row, new bracket. Now, be careful on the -2 that you use the negative key, not the minus key. Right? There's a difference between a negative and a subtraction key on a calculator. -2, comma, 0, comma, 1, comma, 4. Close bracket. That's the end of the second row. Beginning of third row. 1, comma, -1, comma, 1, comma, 0. Close, close. Right? Close to end the third row. Close to end the matrix. And then finally, one last thing. A parenthesis to close the function. This is the exact typesetting as it should appear as you type it into your calculator. All right? Some of them, if you forget the parenthesis, it won't accept it. It'll be a syntax error. Okay. Yes? Now, theoretically here, you could have a matrix with as many rows as you want and as many variables, right? So this is very powerful if you understand the syntax of typing this in this way. All right, now it's going to kick an answer back out to you. Depending on your calculator, it may actually look like a matrix, or it may just look like brackets with numbers. So what does it kick back? Okay, 1, 0, 0, -1, 0, 1. Why? You can. But that's what I was saying. The different models of of these calculators have different ways to put matrix in. You know what I'm saying? I mean, what calculator are you using right now? Okay, if I hand you an 89, you may not be able to type that in. You know how to use the 83, but you may not be able to do it with the 89. This will work for all models. That's what I'm trying to give you, a universal method. It's always an issue. All right. Now, next thing, interpreting this answer. What does it mean? 1, 0, 0, -1. I want to point out, what this means, because it's important, because you don't want to always just look at this answer and think you got it. Like, oh, I've got the answer. It's vital that you have this 1, 0, 0, then your number, 0, 1, 0, then the number, 0, 0, 1, then the number. If you don't have 1, 0, 0, 0, 1, 0, 0, 0, 1, if you don't have that triangle with diagonal of ones, if you don't have that, you don't have the exact answer. Okay? You don't have it. But what does this mean? Okay, what does that mean? A, B, C number, right? So what does that first row now mean? A equals -1. What does the second row mean? B is 1. And what does the third row mean? C is 2. Okay? So we have the answers, A, B, and C. But just what I was trying to get at was be careful. Don't just read these numbers and assume those are your answers. Because if this said 0, 1, 1, 2, that means that there's not an exact solution. You have general solutions, and it's different. You need it to be like this.
Saying is that the A's, the B's, and the C's, those columns,
Mm-hmm.
only 2 of them, 2 out of 3, or all but 1 will be an inner, or will be a number.
Well, if you want to know what A is, the other 2 have to be 0. If you know what B is, the other 2 have to be 0. If you want to know what C is, the first 2 have to be 0. Because you could actually get a 1, 0, 0, -1. You get a 0, 1, 0, 1, and you could get a 0, 1, 0, 1 again. This last one is not always your C. Don't worry, it's not going to happen. This is especially for people who take linear algebra and stuff. All right, I'm almost out of time. What's the answer here? Way back somewhere we had an integral.
Integral x plus 1 plus -1 over x plus 1.
Integral, it was x plus 1 plus, and then it was that 4x over all that junk, right? And we just broke down that 4x over all that junk to be, help me out, A was -1 over x plus 1. Then B was 1 over x minus 1, and then 2 over x minus 1 squared. That's my new integral. Everything over here was what I got from partial fraction decomposition. The x plus 1 was the part I got from the long division. So my antiderivative is 1/2 x squared plus what? X minus natural log x plus 1 plus natural log x minus 1 plus, minus. This one's different. That's not a natural log because of the squared. Well, just like that. See, this integral right here, you can do basic substitution, and it becomes the integral 2, 1 over u squared du, which is really u to the -2. And the antiderivative is negative u to the -1. So it becomes this. I'm not gonna show that, but just make sure you understand how this integral. If you don't understand this, I would just go work it out yourself. That right there.
Is that like substitution?
That's a basic substitution. Okay, I don't know the homework assignment yet, so I'll email you that homework assignment when I get back to my office. All right? Yes? Well, I want to add one more thing to it. Those of you using the TI-89, raise your hands. Okay, the TI-89 has a way that you can put in this original integral, and there is a way to have it do the long division and partial fraction decomposition all at one time. No, you don't even have to. You just put in the integral. It would, if you put it in, the calculator will spit out x plus 1 plus -1 over x plus 1 plus 1 over x minus 1 plus 2 over. It'll do the entire ripping it apart. I'm not going to tell you how. You have to come ask me if you want to know. So you could check. Okay, I'm going to kill the video. Hold on.